Good morning, everyone. Today we are going to discuss about the course content and structure of the course Basic Mathematics BCA 012. Course Introduction. BCS 012 is a 4-credit course. It introduces the students to some basic mathematical concepts, tools, and techniques. It includes determinants, matrices, sequences and series, vectors, three-dimensional geometry, principle of mathematical induction, and linear programming. Objective. The objective of the course is to make students capable of formulating problems in terms of the concepts, applying the tools and techniques to so obtain formulation for solving the problems. In the structure of the course, we have the structure is structured and developed in the form of the 4 blocks, each block containing 4 units. Block 1 includes discussion of determinants, matrices, and principle of mathematical induction. In Block 2, sequences and series, complex numbers, and methods for solving equation and inequalities are discussed. Introductory differential calculus and integral calculus and their application constitute Block 3. Finally, vectors, three-dimensional geometry, and elements of linear programming are discussed in Block 4. In Block 1, we are going to discuss about matrices. When some numbers are arranged in rows and columns and are surrounded on both sides by square brackets, we call it as a matrix. Matrices have types of matrix, symmetric matrix, skew-symmetric matrix. Moving to multiplication of matrices, matrix product AB is denied only when the number of columns of A is equal to number of rows of B. Properties of matrix multiplication for 3 matrices A, B, and C. Number 1, associative law. Number 2, distributive law. Number 3, multiplicative identity. Transpose of matrix. Matrix obtained by interchanging rows and columns of original matrix. For matrix A, transpose of A is denoted by A. Properties of transpose matrix. Determinants. In mathematics, the determinant is a scalar value that is a function of the entries of a square matrix. Principle of mathematical induction. Mathematical induction is a technique of proving a statement, theorem, or formula which is taught to be true for each and every natural number. In Block 2, we are going to discuss about sequence and series. In mathematics, a sequence is a list of objects which have been ordered in a sequential fashion such that each number either comes before or after every other member. More formally, a sequence is a function with a domain equal to the set of positive integers. A series is a sum of a sequence of terms. That is, a series is a list of numbers with addition operations between them. Types of sequence and series. Some of the most common examples of sequences are arithmetic sequences, geometric sequences, harmonic sequences, Fibonacci numbers. Complex numbers. methods for solving equations and inequalities. In this section, we give a process for solving linear equations, including equations with rational expressions, and we illustrate the process with several examples. In addition, we discuss a subtlety involved in solving equation that students often overlook. Moving to the block 3, we have differential calculus, a branch of mathematics concerned with the determination, properties, and application of derivatives and differentials. In mathematics, differential calculus is a subfield of calculus that studies the rates at which quantities change. It is one of the two traditional divisions of calculus, the other being integral calculus, the study of the area beneath a curve. Derivative, mean value theorem. The mean value theorem gives a relationship between values of the derivative and values of the original function. Taylor polynomials in Taylor series. The derivatives gives the best possible linear approximation of a function at a given point, but this can be very different from the original function. One way of improving the approximation of to take quadrilateral approximation, this is to say the linearization of a Lear valued function. Implicit function theorem. Some natural geometric shapes, such as circles, cannot be drawn as the graph of a function. Integral calculus. An integral assigns numbers to function in a way that describes displacement, area, volume, and other concepts that arise by combining infinitesimal data. The process of finding integral is called integration. Along with differentiation, integration is a fundamental, essential operation of calculus and serve as a tool to solve problems in mathematics and physics involving the areas of an arbitrary shape, the length of a curve, and the volume of a solid, among others. Methods of finding integral functions. We have different methods to find the integral of a given function in integral calculus. The most commonly used method of integration are integration by parts, integration using substitution. It is also possible to integrate the given function using the partial fraction technique. In block 4, we have vectors, a quantity possessing both magnitude and direction, represented by an arrow the direction of which indicates the direction of the quantity and the length of which is proportional to the magnitude. Representative of vectors. Vectors are usually represented in bold, lowercase such as a, or using an arrow over the letter, as vectors can also be denoted by the initial and terminal points with an arrow above them. Magnitude of vectors. Types of vectors. Unit vector, zero vector, position vector, equal vector, etc. Three-dimensional geometry. 3D geometry involves the mathematics of shapes in three space and involving three coordinates, which are x coordinate, y coordinate, and z coordinate. In the third space, three parameters are required to find the exact location of a point. Rectangular coordinate system. Three lines perpendicular to each other pass through a common point. That common point is called the origin. The three lines, the axis, they are x-axis, y-axis, z-axis respectively. Distance between 2 points, normal form of a plane. Intercept form, angle between 2 planes. Linear programming. Linear programming may be defined as a problem of maximizing and minimizing a linear function that is subjective to linear constraints. The constraints may be equalities or inequalities. The optimization problems involve the calculation of profit and loss. Linear programming problems are an important class of optimization problems that helps to find the feasible region and optimize the solution in order to have the highest or lowest value of the function. Components of linear programming. The basic components of the linear programming are as follows: decision variables, constraints, data, objective functions. Methods to solve linear programming: simplex method, graphical methods,